Hello, welcome to this video, lesson 1-3, part B. In this video, we are going to talk about even and odd functions. So what makes a function even, what makes a function odd. Okay, so go ahead, make myself small there. And let's look at some definitions about what an even and an odd function is. So for a function to be even, if you replace the x value in the function with negative x, then you will receive the same output, the same type of function, okay? And this is indicative of y-axis symmetry. A function that is odd is said to be odd that if you plug in a negative x, you get a negative f of x for all x values in the domain. And this is similar to what we talked about in the prior video of origin symmetry. Okay, and the way you should remember this is that if a function is odd, it has origin symmetry, right? Both start with O's. Oh, does that make sense? Okay, so that's what we're gonna look here. Okay, so if it's neither even or odd, it's gonna be neither, and that's what the examples here are going to cover. Okay, so they want us to determine, are the functions even, odd, or neither. So what we're going to do, we'll start with a kind of an informal test. I'm just going to plug in a value x equals 2. And I know I've been plugging in x equals 1. However, in this situation, x equals 1 is going to return an output of 0. So I'm going to stay away from any outputs that are 0 because they're not really going to tell us much. So I'll evaluate the function f of 2 is equal to 2 cubed, take away 2, so 8 minus 2, which is 6. And now I want to evaluate, okay, what happens when I make my x values, my input, negative? What's happening at the negative x value? So f of negative 2. Negative 2 cubed, take away negative 2. Don't forget your parentheses, that's important, right? And we get negative 8. Plus 2, which is negative 6. Okay, so I plugged in 2, I got 6. I plugged in negative 2, I got negative 6. That's the opposite output, right? So is that going to be even, or is that going to be odd? Well, that's going to be this case right here, right? I plugged in the opposite, and I got the opposite output. Okay, that's origin symmetry, right? We can also see this is if I plug in f of negative x. Okay, so if I plug in negative x cubed minus negative x, we get negative x cubed plus x, right? And remember, the trick here is to factor out the negative. If I take away that negative, I now have negative x cubed minus x, okay, and this is negative f of x. Okay, so in this example, this is origin symmetry, which they want to know, is this even or odd? So that's going to make this function odd, right? Because it's origin symmetry. So our answer here, I'll just squeeze it in right here. Odd. Okay. Next example, here we go. G of x equals x squared minus 4. So again, I'm going to evaluate. I'll switch back now to 1 because 1's a simple number to evaluate. So 1 squared minus 4. This gives us 1, take away 4, which is negative 3. Okay, and now we'll evaluate negative 1, the opposite number. So negative 1 squared minus 4. Well, this is also, again, negative 3. Okay, so that's going to make this example even, right? This is y-axis symmetry. This is an even function. Okay, for 7, again, let me switch colors here. So x equals 1. I'm going to plug in and evaluate h of 1. This gives me 1 squared plus 2 times 1 plus 2. So we get 1 plus 2 plus 2, which is 5. Okay, and now we'll evaluate -1. So h of -1 becomes -1 squared plus 2 times -1 plus 2. And this is just +1. Okay, in this case, notice how we have 5 and 1. So this is neither. Okay, not opposite, or it's not the same. So this function is neither even or odd. Okay, this video focused solely on even and odd functions. We went over kind of the definitions. We linked them back to the previous video, which talked about y-axis symmetry and origin symmetry. And if it's neither of those, then it's what we call neither. It's neither even nor odd. All right. Catch you on the last video where we're going to talk about points of intersection without a calculator.